Hello Math 8 students. This is Transformation Coordinate Rules. We have finished our unit on transformations. However, we still need to talk about the coordinate notation for these transformations. Although we have mostly described these with words, what we're going to be noticing in today's lesson is that there are ways that we can describe these transformations without using words, using only coordinates, but I want to be able to make that connection from coordinates to the words that we have been using to describe them. To get started, we're going to kind of do a little warm-up here. You can see it here. I have triangle ABC and I have it transformed to triangle A prime, B prime, C prime first. Describe in words that transformation. And then I want you to focus just on point A. What are the coordinates of point A? What are the coordinates of point A prime? How did the coordinates change? I want you to see if there's a way that we can tie in how the coordinates themselves changed to the actual transformation. So pause the video now, give yourself a chance to do that while in-person learners discuss with their groups. All right, who can describe the transformation using the words? Describe that transformation. Logan, get me started, please. Give me more details on that. It is a translation. How many units, sorry? Good, right, 4 units. Fantastic. Now, what are the coordinates of point A? Here's point A. What are the coordinates? Thank you, Dan. 2, 5. Let's just review. That is 100% perfectly correct. Which one is the x coordinate? Nevaeh? The 2, which means that the 5 is the y coordinate. Good. Coordinates of A prime now, please. Thank you, Jacob. 6, 6. And again, that would be an x coordinate of 6 and a y coordinate of 6. So how did they change? To answer this, I want to focus just one at a time. Let's focus just on the x coordinate, please. X coordinate was 2, x coordinate now is 6. How did that change? Nevaeh? We added 4. That's interesting. Because we also went to the right 4. How specifically is the y coordinate changing? It was 5. It is now 6. How did that change? Dan? We added 1. Also interesting because we went up 1 unit. So I want us to make that connection that we can see how these things are being transformed. We can see it and say it in words, but we can also see and make a connection here with just the coordinates. And that's what we're going to be doing, is we're going to be focusing just on the coordinates, seeing these transformations with coordinates only, and then tying it back into the words. So to get started, I've passed out this paper to each of you online learners. You can print the paper or you can just copy down each of these problems. Graph paper is going to be essential if you do not have a printer. So we're going to get started, and it's going to be a little bit tedious in the beginning because we are going to write the coordinates each and every single time. And to get started, it says we are going to be doing a translation where we have our x and our y coordinate, but it's going to go to, that's how we would say this arrow right here. We would say goes to x minus 6, comma, y plus 1. So to make sense of that, we're going to get started by identifying this point. We're not doing a transformation to a whole triangle like we did here. It's just to a single point, which is actually kind of easy because I'm going to make you write down the coordinates, and it's nice to write down just the coordinates of point P. So P, what are the coordinates here of point P? You can look on your own paper because I know it's hard to see up on the screen and to count correctly, so look on your own paper. What are the coordinates of point P? Thank you. Now I've got those hands. Let's see if we can get some fresh new hands though, instead of the same ones. James. 5, 1. And again, that would be our x, y, right? Now again, what I'm doing as I'm rewriting this, I'm rewriting the directions that says take x, y, and make it go to, and I'm sorry, I know that I'm not going to have enough space here, so I'm going to move all of this down here so that I have enough space to do what I need to do. You guys can squeeze it in wherever. You can also do it on a separate sheet of paper if you find that squeezing it on here is going to be too difficult. Okay, so xy though goes to x minus 6 and y plus 1. So what does that mean? That means I'm going to take this x coordinate, and what should I be doing with the x coordinate? I should be subtracting 6. And then I'm going to take this y coordinate, which is 1, and what should I be doing with that y coordinate? Adding 1. Let's make those connections here. Again, I took that x coordinate that was 5. I took that y coordinate that was 1. But then I'm just doing the things that the problem said. It said take that y coordinate, add 1. Take the x coordinate, subtract 6. And now let's do that. Good thing we have calculators because I know it's been a long time since we've done this, but when I have 5 and I take away 6, what do I get? Sorry, I'm going to fix this. This isn't p, this is going to be p prime. So what is p prime? 5 minus 6. What is 5 minus 6? I'll wait for the hands. Thank you. Aiden? Very good. It is negative 1. And 1 plus 1? That one is easy. That one's a 2. So where is p prime going to be now? It's going to be at the location negative 1, comma 2. So let's go ahead and put that down. Negative 1, comma 2. So negative 1 and up 2. And that, let's label it, that is p prime. So we did this using this weird sort of coordinate notation where we found the x and y coordinates, then we took them and changed them the way that it described. And now I want you to describe in words, how did that point P actually change? Here is P, here is P prime. So how did it change? Talk with your groups first. Describe it in words. This is the part where you talk with your groups. Okay, looking for the hands now. Describe it in words. How did P change when it started here and it ended up here? What is the transformation that took place? Okay, not enough hands. That's why I asked you to discuss with your groups. I should actually hear that discussion now. The question I am asking is, how does P change if it starts here and it goes to here? Please take another 20 seconds to discuss with your groups so that I can have more hands than that. Go. Let's see the hands now. Still not enough hands. It's better. Callie? How much to the left? 6 to the left. Let's write that down, please. Translate. 6 left. And 1. Did we go up or down? Up. Make that connection. We took our x coordinate and we subtracted 6. So what happened? I went 6 units to the left. And I took the y coordinate and I added 1 because we went 1 up. I want you to be able to make those connections so that eventually we can get to the point where we don't have to do this every single time. You can just see what's happening here and be able to describe that transformation. And perhaps you're already there, but we need to practice this again. So I want you to now take what we did for number 1, repeat that process for number 2. Find the coordinates of I. Here's I right here. Find the coordinates. Transform the coordinates in the way that it's saying. And it says xy goes to x plus 1, y minus 7. Work with your groups. Online learners, you should pause the video long enough for you to get this done. Come back together when you're ready to discuss. All right, what are the coordinates of I? Again, take a look at the notation that I'm using. I'm going to show my work up here, and I'm just going to rewrite what's happening. Xy goes to x plus 1, y minus 7. But I'm going to write the coordinates of I. What are the coordinates of I, Jacob? Thank you. You're close. It's not 4, 5 though, because I went to the left. So it would be negative 4, 5. Yep. And negative 4, 5. Well, let's see. How is it going to change? I'm supposed to take that negative 4 and add 1 to it. And I'm supposed to take the 5, that's the y value, and subtract 7. So when I simplify that, it's going to be I prime. And I prime is negative 4 plus 1. Nevaeh? Close. Negative 3, yep. And 5 minus 7? Rhett? Negative 2. So I prime is going to be at negative 3, comma, negative 2. Place that point, label it I prime, and describe the transformation. What happened? I started here, it made it all the way here. So describe that transformation. What happened? Lainey. I'm sorry, can you say that one more time? Double check. It's easier to count on your own paper instead of trying to count up on the board. That way you can actually make marks on your pencil. How far down? 7 down. And how far right? 1. Translate 1 to the right and 7 down. And notice, even though Lainey told me 7 down first and then 1 right, I wrote it in the same order because I want to make the connections here that we're going to the right because we are adding 1 to the x value. And that x value goes first, so I wanted to write that x movement, horizontal left-right movement, I wanted to write that first. And we are going down 7 because we are subtracting 7 from that y value. So again, make those connections so that hopefully by the time we get down to 5 and 6, if you're not there already, you can just describe how it's going to change without having to go through that work. Now, before we make it here, we're going to move on to triangles. And triangles have 3 points. So, yes, it's going to be tedious, but I do want you to take the time and write down the coordinates of all of these points. So those coordinates are negative 3, comma, negative 1. S are the coordinates negative 3, comma, negative 4. And Q, 0, comma, negative 1. Remember what we're doing here is we are transforming each of these. So R will become R prime, S will become S prime, Q will become Q prime. And I'm just looking for those coordinates. What are those new coordinates going to be after we perform the transformation that has been given to us? And we already know it's going to be a translation because it specifically told us translation. So remember what we're doing is we're taking our xy, and our xy will go to x plus 2, y plus 1. Again, this process is no different than what we did up above. The only real change is that we're doing it 3 times. Here it was 1 single point. Here it's a triangle, so it's 3 points. But the idea and that concept is still the same. So online learners, pause the video until you get number 3 and number 4 completed, and we'll return on the video to go over them. Okay. The point was negative 3, comma, negative 1, but we are adding 2 to the x value and adding 1 to the y value, so that should be negative 3 plus 2 is negative 1. Negative 1 plus 1 is 0. Make sure you're checking your work here. R prime should be negative 1, comma, 0. I'm going to go ahead and plot that one. Negative 1, 0, and that's my R prime. S, we have negative 3, but we're adding 2. So again, negative 3 plus 2 is 1. We have negative 4 plus 1 is negative 3. So S prime should be negative 1, negative 3. That'll be our S prime. And Q, we have 0 plus 2 is 2. -1 plus 1 is 0. So Q prime should be 2, 0. Which means my triangle in its new position should look like this. And yes, there's a little bit of overlap. How'd you guys do? Looks good? Describe this transformation. How did it translate? Give me that in words. Look at your paper to count if you need to. It's a lot easier to count from your own paper than to count from the board. Yes, sir, Logan. Yep, translate. Translate right 2 and up 1. Again, make these connections. We went to the right 2 because we went and added 2 to our x coordinate. So everything went to the right 2. And up 1 because I went and added 1 to all of the y coordinates. So that is going to take us up 1. Make that connection and how these arithmetic changes to our coordinates result in the changes that we can describe with words here. And here, looking at all of these coordinates, I'm actually going to pause the recording to get all of the coordinates written up there because I don't want to waste a whole lot of video time doing that. All right, so all of these just suddenly appeared because we paused the video to get all of those up there. This transformation, we are translating xy, and xy is going to go to x minus 5, y minus 3. So 5 minus 5 goes to 0. 1 minus 3 goes to -2. Be checking your work here. 5 minus 5 goes to 0. 4 minus 3 goes to 1. 2 minus 5 goes to -3, and 2 minus 3 goes to -1. Plotting each of these points now. J prime is 0, -2. That's the J prime. K prime is over 0 and up 1. There's K prime. And L prime is -3, -1. There's the L prime. So I've got my coordinates in place, going to be building the new triangle now. And then we can see just exactly how it was transformed. And again, we're going to make that connection so that hopefully we no longer have to go through that whole process here for 5 and 6, because we'll just see exactly how it's going to change and make that change looking at those coordinates. And that means this changed. L went to the left 5 units and down 3 units. I'm going to write that down. We went left 5 units, and we went down 3 units. Please help me understand, why did we go down 3 units? What in all of this information here is telling me that we should be going down 3 units? Jacob. Good. I like what you said. One change though. This doesn't say -3. This says -3. But everything else that you said was great. It says we're going to take that y and we're going to go down 3 because we are subtracting 3. And so similar idea here. Why am I going left 5 units? Because it says x subtract 5. We're taking away 5, which means we are going to be going to the left. So with that in mind, I want you to now discuss with your groups. If you still want to go through that whole process and find x prime, u prime, v prime, and w prime, and find those specific coordinates in that same process, you can do that. But now we're dealing with 4 points for each problem instead of just 3. Instead, I hope that we're getting to the point where we can just look at this notation and say, oh, it's going to be moving in this way. So practice that with your groups now. Can you identify the transformation taking place without having to replot every single one of those points? Talk with your groups now. Online learners, pause the video, see if you can write down what those transformations are. Okay, xy goes to x, y plus 4. So, describe this transformation. What is going to be happening here? Aiden, thank you. That is a great guess. It is incorrect. What Aiden said is it's going to move 4 units to the right and 4 units up. But let's take a look and see what's happening. The x is going to go to x. So is it going to be moving left and right at all? No. But the y is going to go up 4, exactly. So it was a really good guess, but I wanted you to pay attention to the x. It is not changing at all. Only the y is changing. So this is a translation of up 4 units, and 4 units up only. We're not moving it left and right. So with that in mind, what is going to be happening here with number 6? We see it's a translation, and xy goes to x minus 7, comma, y. Discuss with your groups again. I should be hearing talking. Talk to each other to confirm what you think or what you possibly discussed last time. Thank you. Now come back to me. In words, what do you think is happening? Jacob. Close. The x-coordinate is changing. The y-coordinate, yep. So the x-coordinate is changing because we are subtracting 7. That's how you knew to go 7 units to the left, because we're going to be getting smaller, so it's moving to the left. And the y-coordinate is the one that is not changing. The y goes to plain old y again. So we're not moving it up and down this time. We're just moving it left and right. Your homework today is I want you to complete 5 and 6. We already talked about what that translation is. Can you actually do that translation? Can you draw the figure in the new place? If you've already done it because you used your class time wisely, then great. If you didn't, then you have homework. We are going to be moving on to the next page where we're talking about reflections. And in order to do these reflections, we have to be really, really precise with our language. So eyes on the screen, make sure you are saying this correctly. We would say reflection xy goes to x opposite y. Please understand that this symbol right here doesn't mean negative, it means opposite. And it might seem a silly differentiation, but it means if it already is negative, we have to take it to its opposite, which would be a positive. It doesn't mean take it and make it negative, it means take it and make it its opposite. Let's go through that same process that we've been through with our other ones. We're going to write down the coordinates of our point. xy goes to x opposite y. And I'm going to call this point A. No reason why. Let's just call it A for funsies. And we're going to write the coordinates of A. A has the coordinates 5, 1. We already did that on the last page because notice that this is actually the same as point P. I'm just calling it point A. And what is A going to go to? Well, paying attention to these little tiny things like x stays exactly the same and is still x, that means that in A prime, 5 is going to stay the same and become 5. However, this y value has to go to its opposite y value. So what was 1 is now going to be the opposite of 1, also known as negative 1. Let's plot that point. That's not A, sorry, that's A prime. So over 5 and down 1, that is A prime. Describe what happened. Again, it tells us that it was a reflection, but it was a reflection over what line? Where's the mirror? Good. Yep, the x line or the x-axis. Reflection over x-axis. Interesting, isn't it? That when we reflect it over the x-axis, the x value stays the same. but the y value goes to its opposite. Now let's do the same thing here with this point. And just for fun, I'm going to name it z. We already know the coordinates of it because it is the same point as what we called I over here, but I'm going to call it z this time. And now it's a reflection where xy goes to opposite x, y. So xy goes to opposite x, y. Writing down the coordinates of z, I have the coordinates of -4, 5. But again, I'm going to take that, I'm going to take this x coordinate, and it's going to go to opposite of x. So here's -4, and -4 is going to go to the opposite of -4, which is a +4. And y goes to itself, y, no change. So the 5 is going to go to 5. Let's plot that new point, calling it z prime. Find it on your own. I should have noticed that before and I didn't. Over 4, up 5. Here is z prime. So describe this transformation. What is happening? Again, we know it's a reflection, but a reflection over what? Callie, reflection over the y-axis this time. Reflection over the y-axis. Again, notice that when we reflect over the y-axis, the y this time stayed the same. When I reflect over the y-axis, it's the x that's changing. The x changed to its opposite. What was negative changed to its opposite and became positive. So we're going to repeat that process here with our triangles. Start by writing the coordinates. We can label this triangle anything we want. I know it was labeled something else on the previous page, but let's just go ahead and call it A, B, C. We would start by writing the coordinates of A, which is -3, -4. Write the coordinates of B, write the coordinates of C, and then perform the transformation that it is requesting. It says x goes to x, y goes to opposite y. So pause the video and give this a try. Do it with 9 and 10. See if you can figure out that transformation that is taking place. Okay, I went ahead and I labeled all of the triangle points and wrote down the coordinates. So you can just take those same labels and the same coordinates and perform those transformations. Okay, now you've had a chance to do it on your own. Let's check your answers. xy goes to x opposite y, so -3, -4 goes to -3, +4. Again, the x value stayed the same and was x value. The y value had to go to its opposite. So -4 goes to a +4 since that is the opposite. -3, x goes to x, so -3 goes to -3. But the y value, -1, goes to its opposite y value, which is a +1. An x value of 0 goes to an x value of 0. Y value of -1 goes to its opposite, which is a +1. Putting those points in place, I have A prime is -3, 4. B prime is -3, 1. And C prime is 0, 1. So again, we can see now that that has taken place, that this was a reflection over the x-axis. Again, interesting to note that when we reflect over the x-axis, the x values are staying the same. The y values are the ones that are changing. And with that in mind, we can probably start making a prediction of what this is probably going to be, since the x is going to its opposite and the y value is staying the same. So x goes to its opposite, 2 is going to go to -2, and the y value of 2 is going to go to a +2, or it will stay the same. 2 goes to 2. 5 goes to its opposite, -5. 4 stays the same and is 4. 5 goes to its opposite and is -5. 1 is a y value, so it goes to itself, the y value. Plotting these points, we now have J prime in position at -2, 2, K prime at -5, 4, and L prime at -5, 1. Building that triangle, we can then see, hopefully the same as you predicted, that this is a reflection over the y-axis. Again, things to note, that when we reflect over the y-axis, the y values are staying the same, and the x values are the ones that are changing. With that in mind, I want you to start making some predictions. Perhaps you will need to still do this one step by step and label each of these points, finding the coordinates, and taking it baby step. But I also want you to get to that point where you can see the x, y goes to x opposite y and make that connection. What is going to be happening? Here we have the reflection xy goes to opposite xy. What is going to be happening? That is your homework. If you need to do it step by step and list these points out one by one and take it all step by step there, you can do that. But if you can also just figure out what transformation is being described here, you can perform that transformation and put that image on your coordinate plane. So again, your homework is completing anything that you didn't finish here on this first page, like 5 and 6, and completing anything that you didn't finish here, 11 and 12. That's it for today. We'll see you next time.